Welcome. Thanks for coming. I will be talking about machine learning for designers, and while I was doing the slides, I just somehow realized, well, actually it's more machine learning for people with just a fuzzy idea about what it is actually. It's not only directed to designers, it's more directed to, well, a lot of people that sort of have heard it, know that it's important that they know something about it, and it's mostly designers because they don't exactly know what it is about, but I guess it's not only that. So, what is machine learning? Whenever you go on Netflix, you will see a lot of suggestions. So these recommendations, they come with a match score, and Netflix uses machine learning to predict the probability that this is something you will like, or that this is something that matches your usual watching habits. So machine learning is actually everywhere, and it's machines using algorithms that can receive input and make predictions from it. So they can predict an output value. This is a very generalized definition of what machine learning is, but for the sake of simplicity, we can work with this. So the important part is algorithms, and data comes in, they do something with it, and they predict some value. So the machines using algorithms, that's actually the learning part of the whole machine learning. And there are three methods how machines can learn. And they are very distinct from each other, and in daily work, one is the one that is important, especially for beginners, and this is supervised learning. So supervised learning is you train the machine with a data set, so you have a training set, and the machine can then generate results by learning this data set and making a prediction based on that data set. So it's sort of like you teach, and then the machine does something according to what it learned. Unsupervised learning is when you have a lot of data and you sort of don't know what to make of it, and you can feed that into an algorithm, and the algorithm is actually built to figure out interesting stuff. So it shows you anomalies, it shows you things that are out of the norm, it shows you patterns, it shows you just things you wouldn't spot if you do it as a human. Machines are much more able to do that than humans would. And then the third method, there are more methods, but these are the really main three ones, is reinforcement learning. And this is more based on how humans actually learn. So when kids learn to walk, we don't teach them rules. So this is how you walk. But they learn it themselves. So they make an action, the environment, they get some stimuli from the environment, or some feedback from the environment, and they learn from that. So it's like a loop that keeps on shaping the knowledge of the machine. So the machine continuously learns from its action and the feedback of the environment. That's how machines learn to drive. Self-driving cars learn by reinforcement learning. The number one method for machine learning that people will use is usually supervised learning. And supervised learning works like this. then you start making records. So you sell a house, it has 4 bedrooms, 96 square meters, it's in Ipswich, it has 2 floors, and the sale price is 1.5 million. And you start making this list, and the goal is to have a training set you can then give to an artificial intelligence or a machine learning algorithm, and it can give you a sales price for any combination of these. So you have the features, and you have a target. And supervised learning, you give the machine a training set with features and the target values. It figures out how each feature is weighted. So how important is it that it's in this neighborhood? How much does that play into the price? Or how much does the floor scheme play into the price? And it evaluates like factors for each feature. And then it creates, the artificial intelligence creates a formula for what is the best price you can get for any of the feature, for any feature set. So the goal of supervised learning is to train with features and targets and to be able to make predictions of possible targets for any feature sets you have, or for future feature sets. Character recognition is a typical example of supervised learning. So you have all these symbols, and they all represent the figure 8. And you train the machine to recognize this thing, and it analyzes every image, and it learns to see the numbers 8, and it learns to distinguish them from 1, 2, 3, 4, 5, 6, 7, and so on. Or you have owls. You give them a bunch of pictures of owls, and it learns how owls look like. But then, okay, is it an owl or is it an apple? So you train the machine to learn what matches and also what not. So you learn it, you teach it to make distinctions between things. So you would deliberately show it in the training set there would be apples, and it would say no, not an apple. And so the machine would take that into account and would learn, okay, if the picture has these characteristics, it's probably not an owl, because they're really close together. And obviously, this is an edge case, and it makes sense to train image recognition with edge cases to make sure that you don't have any false positives. The goal is to have to reduce the number of false positives and to have a true rate of recognition. Machines using algorithms. This takes a lot of data, and really a lot. So the more data you have, the bigger the training sets you can establish, the better results you will get. It's very trivial. For example, emails. So if you want to make a spam filter, you need a lot of emails to train the training set. Usually you take data and you pass it through a generic algorithm, which is some sort of formula, mathematical formula. It comes from statistics, it comes from all sorts of fields, and the machine takes the generic algorithm and figures out the details of of how the algorithm or how the formula is applied to the data set. So if you had the houses before, it will figure out which feature is weighed in what way. So there is tons and tons of these generic algorithms, and machine learning is just taking these and feeding them with data and seeing what happens. So you have events, you feed them into a generic machine learning algorithm, and you let the machine figure out the rest, and the result would be, okay, there is a classification of spam or no spam. So these generic algorithms, there are a lot of generic algorithms that exist already. You will probably not be inventing generic algorithms in your lifetime. I don't know, maybe some of you are mathematicians and you will do, but it is likely you won't. And this is not bad, it's okay. And the cool thing is you can use generic algorithms to solve completely different problems. So the same generic algorithm can be used to make a spam filter, but it can also be used to make a classification system for news articles. So you have an editorial system where editors write articles, and the machine learning algorithm analyzes the headlines and the body text and says, okay, this is from politics, or this is from finance or sports, just by looking at the content. And it's the same algorithm. There are roughly two types of algorithms that you will encounter. There are more, but these are the big two ones. You have classification algorithms that tell you, like the email thing, that tell you something belongs to one category or another category. So the goal is a prediction of discrete values like true, false. Cancer in oncology is the mole benign or is it malign tumor? Spam, is it not spam? Things like that. And then you have regression algorithms. These are the algorithms that compute continuous values, like houses, the prices of houses, or the likelihood you are going to get cancer again, for example. Like really numbers that can vary, that are not strict categories. A big part of machine learning is about classification. So a lot of things we do are in the field of classifications. So this is something, if you're starting out in machine learning, look at these things, look at classification patterns, what are examples where classification is used. One big thing is image recognition. So this is Chihuahua or laughing. So most image recognition things are about classification. For example, that you can take pictures of your skin and it tells you this is a benign mole, or you have to go to the doctor. That you can take photos of an eardrum and it tells you, hey, you have to go to the doctor, this is infected. All the medical applications, or a lot of medical applications, are classification problems. And there is a huge potential for applications that use classification in respect to image recognition. And this will be very important also for not only for developers but also for designers to know about this. So actually is everywhere. Our field, the design field at large, is moving fast and rapidly towards convergence of industrial design, service design, and interaction design. For example, this is an otoscope. Well, this is a cell phone, and this part here is an otoscope. And the otoscope is the thing that takes pictures of your eardrum, and it shows you. You can take a picture and you can send it to the service, and the service will analyze it through machine learning, and it will give you feedback. Go to the doctor, don't go to the doctor, you're fine. And this is an example of these fields coming together. And machine learning is a huge driver for that, that shift. The machine learning is taking over many parts of the design process, of how we think about services, how we think about appliances. They're not enclosed little things, but we start to connect things. So future design teams will unite these disciplines. We will not only unite interaction design, service design, and industrial design. We will have to know about artificial intelligence. We will have to know about linguistics for voice recognition and conversational design. So all this is coming together, and machine learning is one part of that. So design is becoming physical, it's becoming automated, it's becoming connected, and machine learning is the part that is responsible for a lot of movement in that field. Okay, thanks. I'm Rattlesnake, and I like to give some advice.